And good morning, everybody. Dan Thomas here at News 4 for Facebook Live Weather School for Kids. We do this every weekday morning on the main WSMV Facebook page. Always so much fun, so much learning. Pardon me, and if you've watched my segments before, I've done probably 5 or 6 of these. So many weather demonstrations and experiments. And so today I will not let you down. We'll do more demonstrations and experiments and have fun and do some things that you can do at home if you would like to do so. Kids love these things, and as I'm finding out, adults love to watch these as well. Always focused on weather or science-related things. And so what we're going to do today is we'll spend probably 10 or 15 minutes talking about a number of different things. First and foremost, we're going to talk about the wild storm events we've had for the last 2 nights. Those have not been normal thunderstorm events. Both has been very unusual for a reason or two, and we'll talk about that. And then we'll transition into some fun things like, why is the sky blue? Why does the sun look yellow? Why do sunsets sometimes look red? So we'll cover those things, and then we'll actually make a little demonstration that you could do from home, and you could make what looks like a blue sky, and you can make what looks like a yellow sun, just like that. And then we'll talk about thunderstorms. You can see these crazy strings, and we've got them set up across the room. My kids over there, Sadie and Hudson, will participate and help in our little balloon racers. Hudson, you going to have fun? And then we're going to bring back from last week or the week before an experiment that did not go so well, and I feel more confident that it's going to go pretty well today. So let's get right to it. If you have questions, as always, feel free to ask. But Weather School for Kids, 11 o'clock Monday through Friday on the main WSMV page. Now, the last 2 nights we had big thunderstorms. This was 2 nights ago, but I want to talk about last night because last night was strange. Last night's event was the circumstance where we had some rain, some lightning, some thunder in Nashville, and then the storms moved away, and then the wind picked up. That doesn't happen very often. Typically we have the very high wind with the thunderstorms as we had 2 nights ago, but last night the rain stopped, and then that wind picked up. So many times I've talked to you on Facebook Live about how wind goes from areas of high pressure to low pressure. You know, your fingers can make pressures. We talked about in the first week, you put 2 fingers on one hand and push it down on the other wrist, and that little force over that little area is called pressure. So your fingers can make pressure. Air makes a whole lot of pressure. And so air pressure last night within the thunderstorms that were south of Nashville was very high. But as those storms moved away, we had a lot of low pressure in Nashville. And the difference between the two made for the very windy conditions last night after the storms moved out. So, you know, Nashville looked like it was just going to get some rain, but then things caused more power outages with that strong wind. 30,000 people last night in Nashville lost power again once the storms moved away. Now, this is the system 2 nights ago, and so the circumstance last night was called a wake low. That's just the phrase in meteorology. This is called a derecho. So they rhyme. So we're getting into some tricky meteorology terms, but a derecho essentially is a big, long-lasting wind storm that's made by a fast-moving band or line of showers in severe thunderstorms. So it's going to be really nasty wind, and it's going to happen for a very long time, and the wind has to be super strong, and it's going to go over a very big area. We had a derecho in Middle Tennessee on Sunday night. We don't have these often at all. In fact, we had one last summer, but typically it's every 3, 4, 5 years, something like that. Take a look at some of these pictures. This is a thunderstorm, and so here's the ground, and so the thunderstorm makes a lot of cold air, and then that cold air runs down and hits into the ground and causes things to blow down, like trees and power lines. So we talked about this last week. This is our radar, forewarned real-time radar. Here's Nashville. So if you live in Franklin, here's Franklin. If you live in Murfreesboro, there's Murfreesboro. There's Lebanon, Clarksville, and Hendersonville, and then the rest of Middle Tennessee. Sunday afternoon, here comes that big, long line of storms. And what it did was move across Middle Tennessee. Here's 3:30 Sunday afternoon. Here's 4 p.m. Sunday afternoon. Here come the storms getting close to Nashville. Here's 4:32 as the storms and the really bad wind hit most of the Nashville area. This is when all that wind got really crazy and the trees blew down and the power lines blew down. And then 5 o'clock, the storms were east of Nashville, still causing more wind damage. And then notice, as we continued to go to 5:30, still some very strong storms. This shows, it's unbelievable. This shows, can you see Tennessee? The state of Tennessee is right in through here. Look at all this area right here, blue dots. Those indicate where we actually had damaging wind gusts. These storms started 2 days ago. So they started Saturday back in Kansas and Nebraska, and they rolled all the way across Missouri, western Kentucky, and into Tennessee. That is a derecho. And so you went through a derecho the other night. These are the wind damage reports. Here's Tennessee again right here. Wind damage reports last night. So much more localized in southern middle Tennessee. But 2 nights ago, it was unbelievable. This is not from the event that we had Sunday night, but this is a similar event that happened years ago. And you can see all the storms moving along many states. So they impact many states as they move along. Is there somebody at the door? No. Oh, what's up? Oh, terrific. Thank you, guys. They want me to use this toward the end of my experiments. Maybe I'll try that at the end. All right. Thank you, guys. So now let's talk about, you know what? Let's do the balloon racers thing, because this shows, my wife is like, yeah, let's do the balloon racers thing. This shows what we talked about 2 minutes ago. All right. Sadie, you're going to get in position, and you can do this from home. That high pressure, air goes from high pressure to low pressure. So this is fun. The kids had fun with us yesterday. All you need is some string. So you need a ball of string. You need a pair of scissors. You need some balloons. And you need some Scotch tape. I forgot the tape. Let me get some tape. And so, and then you need some kids who are interested in having fun. So what we're going to do is blow up 2 balloons. I've got, these are good balloons, actually, where they can get pretty big. There's a whole lot of air pressure in this balloon right here. And so I'm not going to tie it. Instead, I'm going to sort of twist it off a little bit and use this little binder clip and lock it in place. And so I can get it. Silly kids. Okay. Good. So that one's ready. Hudson, may I have that, please? Please leave that right there. Okay. You guys get in your position. Don't trip on the light.
Where's my straw?
One more. Okay. We'll give you the pink. Now let me find that other clip. Is that other clip over there?
Yeah.
Good. All right. Watch out, Sadie. I don't want to trip on these lines. Yeah, so this can keep the kids busy for a while. It's better if they can blow up their own balloons, but if you have to do it for them, oh well.
It's gonna
Now,
seem like a fart sound.
so what we're gonna do is take this and point where the air is going to come out backwards, and we'll show that the air goes from the high pressure in the balloon out the back, and then we race down the straws, because we need a straw for this as well. Just like this. So Sadie, get in position, please. All right. Okay. Now you guys remember to wait until I say go. Yeah, we can tell. That's good. Okay. All right. Kids, Sadie, go get in position. Hold on until I say go. So, I've tied off the string across the room. We've attached, and it's tight string. We've attached straws. We put a straw through or string through the straw. They're going to take the clamps off, and we'll see whose balloon gets there first, because the high pressure releases to the low pressure. On your mark, get set, go. Yeah! Ooh, that worked well. So Sadie beat Hudson just by a second. Okay, let's transition to this other thing. Let's come back over here. Hey guys, Guys, would you go sit down, please?
Steve Paul says this is so much better than watching regular TV.
Good. Guys, go ahead. Hey, Sadie and Hudson, go have a seat at the table, please. Let Daddy finish. Thank you. All right, so now let's talk about, hey, Hudson, would you go sit at the table, please? All right, now we're going to talk about why the sky is blue, why the sun is yellow, and why clouds are red. Look at the sky here, beautiful blue sky. Sometimes we have nice red sunsets. And so you can do this from home to sort of understand why this happens. And so essentially what happens is light comes from the sun. So light comes from the sun, and it comes into our atmosphere. We've talked about the atmosphere a number of times. The atmosphere is that layer of air that surrounds the Earth within about 200 miles of the Earth, held down by gravity. And in that atmosphere is a ton of air molecules. All the air we breathe in, molecules, if you know what a molecule is, it's the smallest, the tiniest little amount of something we can have. So we have little tiny water molecules in the air. You can't see them. You can't even see them with an everyday microscope, but they're there. And we have all different air molecules. So what I'm going to do is I'm going to take this glass. I'm going to take it over to the faucet, get some water in it. I'm going to fill it up halfway. Now, the thing about the air molecules that we have is that they're very important. Sadie, would you go please sit down? Anybody with kids that are out of school understands my struggle right now. Sit. All right. All right. So I'm going to set this water here, and so this is going to represent the outer space. But what we're going to do is turn this outer space into, I want to just put a hair more water in here. We're going to turn this outer space into our atmosphere by adding some pretend air molecules with milk. So I'm going to get from the refrigerator some milk, and any good scientist has a shot glass. So I've got my shot glass here ready to go, and I've got my kids' milk. All right, and so I fill up the shot glass with milk, and so I have a light. This is my little headlamp that I use when I'm just going in the crawl space or whatever. All right, so I've got it turned on. And so take a look through this. This is just water, nothing fancy on a white background. What do you see? You see really nothing but water. The white, the light looks white and not very fancy. Hudson, please go sit down. Sadie, please go sit down right away. Guys, you helped so much, but today you're not listening too well, so I'd like for you to go sit down. Now what we're going to do is we're going to just take half of the shot glass of milk and add it to this water. No big deal. And so, just a hair more. And so, as you look at that from home, what does that look like on the camera? Does that still look just like normal? Yeah, I mean, it looks like, take a look. This looks like sort of nasty, cloudy water. But what we do is we add light to it. And so, this is the way the atmosphere works. The milk droplets, I don't know if you can see bluish, stay on this side right here. The milk droplets are actually bending the light. They're scattering the light. And because visible light, or the light that comes from the sun, comes from is comprised of all different wavelengths, all different colors, we're able to see, because of the milk droplets, some blue show up there. Can you see that? I don't know if it's resolving at home at all. Yeah, it looks bluish. Now, and then, right in through here, it sort of looks greenish. Let's make the color of the sun. So again, take a look at this, and this is still without the light, just cloudy water. Let me put in the rest of the milk. And now, not only does it look even more bluish, but now take a look from the top. It almost looks like orange juice, and it looks like we've got a yellow sun. Can you see that? I don't know how that's looking at home, but you can do this at home as well. Because the milk droplets are acting like air molecules, they're scattering that light and making different colors. Now, if I add some more milk, and I'm going to add a hair more, this will start to look a little orangey. So what that tells us is when we have nice red or orange sunsets, the sun's light goes through a deeper layer of atmosphere, so more molecules scatter the light, and give us varying colors. Now, it's not going to look like super orange, but does that look any more orange? Let's see if I can add that. If you shoot it from the top down, does that look a little more orangey than it did before as opposed to yellow? Maybe. It's tough on this Facebook live video, but sort of neat. And again, I hold it up, and it just looks like milky water or even just plain milk. So let's do our last two experiments. These are ones that I brought back from a week or two ago because I was very disappointed on how they worked. And this will be the end. We'll take any questions that you have. So I did this. I was so angry this didn't work. I thought it worked, but then my mom said, she watched and she said, I couldn't see any cloud. This is just a normal, excuse me, Hudson, this is just a normal drinking bottle that we got at the store. And so finished it up, covered it up, and now I'm going to actually twist it to make a cloud in here. We're going to really ratchet up the pressure, the air pressure in here, as much as we can. And we've got a couple bottles to try if this doesn't work, but this should work. So I've really jacked up the pressure, increasing the temperature in here, forcing some of these water molecules to go in the vapor state. And then when I quickly open this cap, you'll see a cloud form instantly. Watch. Now, did that work? Anybody can do that at home. We got one more. Again, nothing special about this. So I'd get it halfway through. Make sure the cap's on good. Now, why this failed last week when I did it is because I didn't get the cap to come off instantly. You got to really, I'll show you what I'm talking about. Like, I'm not just going to grab it here. I'm going to grab it way back here so I can make a full turn and get that cap off very quickly. Let's see. You ready? That's a real cloud. No magic there. Real cloud in a water bottle. So you can do that and amaze your friends when you go back to school. Hey, that is it for Facebook Live. I'm on News 4 at noon, so I have to get ready for that show. We've got a couple of fronts coming. We've got some cold air this weekend. A lot of people are starting to wonder, hey, am I going to have to protect my plants? Am I going to have to pull out my tomato plants and get them ready to deal with the cold weather we have coming this weekend? So we'll talk about that on News 4 at noon. Any questions before I let you go?
I do not see any.
All right. Well, we had fun. I hope you had fun as well. Have a great day. And tomorrow, excuse me?
Happy Cinco de Mayo.
Happy Cinco de Mayo. All right, terrific. Have a great day, and we'll see you on News 4 at noon. Take care.